In this video, we're going to look at the intersection between lines and circles. So let's take this first example. A circle C has equation x minus 5 all squared plus y plus 3 all squared equals 10. The line L is a tangent to the circle and a gradient of minus 3. Find two possible equations for L given your answers in the form y equals mx plus c. So what we have here is we have a sketch. So notice that there's a line passing through the center and that's perpendicular to both tangents. So let's draw a right angle here from circle theorems from GCSE. The angle between the radius and the tangent is 90. So got that there. And our goal is to work out what these two intersection points are between the line that passes through the center and the two tangent lines. So that's essentially what we need to work out. And we need to work out these final two equations of both tangent lines. But what we've been told is that this gradient, call it M1, has a gradient of minus 3. Now, because it's perpendicular to the line that passes through the center, I'm going to just label these so it'll be easy for us to read. So we've got L1, L2, and what we want is the equation of L3. That's the line that passes through the center. So we know from GCSE that M1 times M2 is equal to minus 1. Therefore, M2 is minus 1 over M1. So in our case, it's minus 1 over minus 3, and that's going to be equal to a third. Now, what we also know is we know the point that L3 passes through. So we can say the equation for L3, so equation of line L3 is y minus y1 equals m times x minus x1. So we can then form the equation of a line that passes through the center. So in our case, it's y minus of minus 3 is m in our case is a third. Now we're going to multiply that by x minus 5. Now I'm going to keep my equation in terms of y and I'll explain why in a moment. So x plus 3 is equal to a third of x minus 5 over 3. Now we're going to simplify this down, so we get a third of x minus 5 over 3 minus 3. Don't forget this is 3 over 1, and we can only add or subtract fractions if we have the same denominator. Hence I'm going to times that by 3 times that one by 3, and continuing with the algebra, we're going to say y equals to a third of x minus 5 over 3 minus 9 over 3. So we get a third of x minus 14 over 3. Now that's the equation that passes through the center of the circle. That's what we marked in our diagram, L3. Now notice that we've been given the equation of a circle. Because they intersect, I can solve a simultaneous equation, because that's what a simultaneous equation is. It's when two lines intersect, or in our case, the line and the circle intersect at that point at L3. So I'm going to equate the y here and substitute what y is in my equation. So we now have the equation for L3. So I'm going to write out the equation of the circle. So it's x minus 5 all squared. Now notice I'm going to write in my equation for y, and I'm going to write it as what we have here. So a third of x minus 14 over 3, and then what we're going to do is put a plus 3 here. This is 3 over 1, and it's squared, and it's equal to 10. So we can only add and subtract fractions if we have the same denominator. So we're going to tidy up the algebra here. So we get x minus 5 all squared plus, now what we get here is a third of x minus 14 over 3 plus 9 over 3. It's squared, and it's equal to 10. So now what we're going to do is we're going to get x minus 5 all squared plus a third of x minus, that's going to give me 5 over 3 all squared equals to 10. So at GCSE, your teachers, or certainly I would have taught you this, that a plus b all squared is equal to a squared plus 2ab plus b squared, and also a minus b all squared is equal to a squared minus 2ab plus b squared. So what we can do here is we can use this to expand two brackets out very quickly. So that will give me x squared. Well, x times 5 is 5x, double it gives me, in our case, 10x and minus 10x plus 25. So here, expanding the second bracket, we're going to get a ninth of x squared minus 2 times 5x is 10x over 9 plus 25 over 9, and all of that is equal to 10. So what I'm going to do here now is to times everything throughout by 9. So we get 9x squared minus 90x plus 225 plus x squared minus 10x plus 25, and all of that is equal to 90. So if we simplify our equation down, what we're going to end up with is 10x squared. Now minus 90x minus 10x is minus 100x. That gives me 250 is equal to 90. Minus 90 on both sides. So we're going to get 10x squared minus 100x plus 160. Now all of that is equal to 0. So now what we get is x squared minus 10x plus 16 equals to 0. So what we get x squared minus 10x plus 16 equals 0. Factorizing the quadratic and solving it, we get x minus 8, x minus 2 equals 0. Now we're going to solve that. So we're going to solve that to give me x equals 8. Or x equals 2. So because these are the points these are the coordinates of the intersection points of the line that passes through the center that meets the circle, where the two tangent points also pass through, we need the y coordinates. So we have an equation for y, and that was y equals a third of x minus 14 over 3. So we're going to write that down here. So y equals to a third of x minus 14 over 3, and we're going to substitute when x equals 8. So when x equals 8, we're going to say y equals a third of 8 minus 14 over 3, which is minus 6 over 3, hence y is minus 2. So our first point of intersection is 8 and minus 2. Now we're going to do the same when x equals 2. So we're now going to say when x equals 2, we can say y equals to a third of 2 minus 14 over 3. So we get 2/3 minus 14 over 3, which is y equals to minus 12 over 3. That's going to be y equals to minus 4. Hence, we're going to get 2 and minus 4 for our second coordinates of intersection. So now we're going to work out L1. So we're going to say y minus y1 is m times x minus x1. So in our case, y minus minus 4 is minus 3 x minus 2, y plus 4 equals to minus 3x. Be careful, minus times a minus is a plus, so we get plus 6. And we can solve that equation, minus 4 on both sides. So therefore, minus 3x plus 2 is the equation of L1. So I'll just annotate that. That's the equation for line L1. Now we need the equation of line L2. Now L2 has the greater x coordinate, which we worked out, that was 8. So the same thing as before, we're going to say what x1 is, that was 8. We need to write down what y1 is, going back to our coordinates. So we've got that when x was 8, our y coordinate was minus 2. So meaning our y1 is minus 2, and m, they've told us originally the gradient of the tangent lines were minus 3. So again, same formula, y minus y1 is m times x minus x1. So we get y minus minus 2 is minus 3 x minus 8. So y plus 2 is minus 3x plus 24. And again, you're going to minus 2 on both sides of the equation here. So therefore, line L2 has equation y equals minus 3x plus 22. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So what we're going to do first of all is draw a line through the center. So we can draw a line like so that passes through the center of the circle, and the most important thing is it's got to be perpendicular to both tangent lines. So I'm just going to slightly move it down a little bit here, and it goes like that, and like that as well. That would be good enough for the sketch. I'm going to do that in green, and don't forget that it's at a right angle, because the angle between the radius and the tangent from circle theorems is 90 degrees. So just like our example, we need to write down the center of the circle. So minus 5 comma minus 3. So there we have the center of the circle. Now it meets the tangent here and here before, And they've told us that the gradient of both lines, of the tangent lines L1 and L2, are 2. So again, like the example, M1 times M2 must be minus 1. M2 is minus 1 over 2. So we're going to say that the equation, let's call this L3 of L3. You must have clear headings in your working out when you're working things out for the examiner to understand your work. So the equation of L3 is going to be y minus minus 3 is minus a half of x minus minus 5. So that works out to be y plus 3 of minus a half x plus 5. Expanding the brackets, y plus 3 is minus a half x minus 5 over 2. So what we get now, minus a half x minus 5 over 2 minus 3 over 1 times by 2 times by 2, and then we're here now going to get minus a half x minus 5 over 2 minus 6 over 2. So we get the equation of L3, or the line that passes through the center, minus a half x minus 11 over 2. So then what we can do is then substitute this into the equation of the circle. So x plus 5 all squared plus y, in our case, minus a half x minus 11 over 2 plus 3, in our case 3 over 1, and we're going to square this, so times by 2 there. So expand this out in this next line. So x plus 5 all squared plus minus a half x minus 11 over 2 plus 6 over 2 squared, and that's going to be x plus 5 all squared plus minus a half x, and that will give me minus 5 over 2 all squared. Right, so we got up to this point here. So what we're going to do is we're going to expand this out. X plus 5 all squared. Then now here what we're going to get is plus a quarter of x squared plus 2 times minus a half x times minus 5 over 2 plus 25 over 4 equals to 80. So we get x squared plus 10x plus 25 plus a quarter x squared and the minus and the minus cancel out, the 2.5 cancel out, so minus and the minus is a plus, so I get a plus. The half and the 2 cancel, so I get 5 over 2 x plus 25 over 4. Now that's equal to 80. So now what we end up with, we're now going to times throughout by 4 to get rid of the denominator. So I get 4x squared plus 40x plus 100 plus x squared. We're times it by 4, so we get 20 over 2, which is 10x plus 25 equals 320. So I get 4x squared plus x squared is 5x squared. 40x plus 10x is 50x. And 100 plus 25 is 125. And that's equal to 320. Minus 320 on both sides. We're going to get minus 195. So we're going to form our quadratic equation now. So we get 5x squared plus 50x minus 195 equals 0. Divide throughout by 5. And that gives me x squared plus 10x minus 39 equals 0. Factorize now quadratic. We get x plus 13x minus 3 equals 0. So solving that gives me x equals minus 13, x equals 3. Don't forget our y equation we had was y equals minus a half x minus 11 over 2. So let's write it down here. So we're going to substitute minus 13. So it's minus of minus 13 over 2 minus 11 over 2. So that's 13 over 2 minus 11 over 2. So that gives me 2 over 2, which is 1. Now I'll do the same thing here when y equals to minus a half x. So putting the 3 here, minus 11 over 2. 3 over 2 minus 11 over 2. And that's going to give me minus 14 over 2. And that works out to be minus 7. So our points of intersection are as follows: minus 13 and 1, and we're going to get 3 and minus 7. So now we know that, going back to the question, that the gradients of L1 and L2 is 2, so we can now form our equations. So let's work out L1 first, and that's going to be the equation that has a negative x coordinate. So let's do that first. So line L1 is y minus y1 equals m times x minus x1. So we're going to get y minus 1 equals 2 times x minus 13. So y minus 1 is 2x plus 13. Y minus 1 is 2x plus 26. So we're going to get line L1 therefore is 2x plus 27. Now for L2, we do the same thing. So y minus our other equation, so y minus 7 is 2 times x minus 3. So y plus 7 is 2x minus 6. Y equals 2x minus 6 minus 7. So y equals to 2x minus 13 as our second equation.